Hello, folks, and welcome back to Learn Synthesis with Pure Data. I'm your host, Dr. Lawrence W. Moore. This is our fourth and final episode in building a granular synthesizer. We are in Series 2, Episode 4, and right from the beginning of this series, we've been making a granular synthesizer by first making a looping, recording, and playback sampler, and then adding granulation to it. And then last time in episode 3, adding panning windows to smooth out that granulation. Although it didn't get as smooth as it could have because there was two things that I missed in last episode that I want to correct at the beginning of this one. So in this episode, we'll be finishing this granular synthesizer. I may come back to it in future series and my other series and stuff like that and using it. I'd like to make it a nice modular granular synthesizer I could pop into with other modules and mix and match and do some cool things with it. But in this episode, we're going to add two more functions to it that are pretty much already kind of there, but we're going to make them actually more functional. And we're going to use the graphic user interface to make a more easy to use system of granulation. So this one will be a little less heavy than the other ones, but it will still get us to where we want to be and having a well-performing granular synthesizer. Okay, so here we go. All right, so on disk, what do we have? We have modules.pd and we have granular_mono_pd. That granular_mono is this abstraction that is loaded into the modules PD file, which is the parent patch here. This would be like a patch where you could drop in different modules and link them all together. And that's why I made this an abstraction just for the future in order that I could, connect it to other things and, do stuff with it. I like to build things as abstractions. Now, this is where we left off last time. Notice I am back in PD Vanilla. PD Lorc is fine, except that it was not, when using an abstraction for some reason in PD Lorc, a lot of the GUI objects, like our toggles here for record and playback, and our slider here, the colors weren't showing through. Another setback is then when I loaded things in PD Vanilla, even though all the things I've used in this patch are things within PD Vanilla, these graphic user interface objects lost all their properties. And so I had to put in their send and receive symbols again, and some ranges correction for the slider. And so I was able to get it back into working in PD Vanilla, and I think I'm just going to stick with it that way. PD Lorc I'm using in my Exploring Multimedia Art with PD Lorc series, and there it definitely plays an important role. But in this series, I thought I'd just use it there because of the curvy patch cables, it might be easier for people to see what I'm doing. But, with this mostly being a pure data series, I don't want to PD Lorc it, and I didn't really get any feedback saying that it was any better with the patch cables. In fact, I received an assignment where there was a lot of things hooked up wrong, and I'm like, well, I guess the curvy cords didn't help. But whatever you are using in this series already, just keep using what you're using. All this will work in PD Vanilla, it'll work in PD Lorc, and it'll work with Pure Data. The only thing is going back and forth between one flavor of Pure Data with another, that it might present some difficulties. And so far I found that as long as you're not using some of the externals in Pure Data, it goes back and forth with PD Vanilla pretty well. But PD Lorc, as soon as you save it in Lorc, some things happen that when you try to open in Vanilla again, you're going to have some problems. So In any case, anyone following the series, just keep using what you're using. Okay, that being said, this is where we left off last time with it sounding like this. Hello there, I'm talking to you, and you'll notice that it sounds a little bit wonky. Hello there, I'm talking to you, and you'll notice that it sounds a little bit wonky. Now, I know we're granulating and doing this effect, and for those, and for, episode 2, when we were just doing granulation without the handing windows, I was like, of course it's going to be distorted. We need to add the handing windows. And when we added the handing windows, it sounded better, but there was one thing that I did wrong. Here, if we open this up, this is the granular _ mono patch underneath. And we're going to go to playback here. And what I did was I was looking at some patches I had in the past that I took screenshots of, and I misread something. This multiplier here should actually be an adder. Basically, these are two different phases of the same granulation. And so this phaser is driving it, but this here, by adding 0.5 to it, we're shifting it out of phase by 180 degrees so that the handing window that's being used here and the handing window being used here are out of phase with one another. In other words, when one's sloping in, the one's sloping out. When the other's sloping out, the other one's sloping in, and they interlace well. And that's what smooths things out. In addition to that, out of wrap, just like I have over here with Phasor, it should be going to the right inlet of samp hold. I just totally missed hooking up that cable. So now let's hear it doing that. Hello there, I'm talking to you, and you'll notice, and we get a much smoother sounding playback. That is the whole purpose of the handing windows, and it fell short at the end when I put this stuff in, and I just, used a multiplier instead of an adder, and I forgot to hook up the samp hold. Hello there, I'm talking to you, and you'll notice that it sounds a little bit wonky. Hello there, I'm talking to you, and you'll notice that it sounds a little bit wonky. Hello there, I'm talking to you, and you'll notice that it sounds a little bit wonky. Hello there, I'm talking. So there you can see things sound much smoother, but we still do get that speed change effect when we lower the speed of playback. Now we're going to add a couple other features, meaning two more sliders to change grain size and grain speed. We already have grain size and grain speed incorporated into the patch, but now we're going to make them adjustable. Before doing that, there's one thing that I want to do here. Since we're going to have grain speed, we shouldn't have a slider that just says speed. So we're going to change this to playback speed. Might as well put the underscore in. PD will do that anyway for the labels that you type. And I'm also going to identify this as playback speed instead of just speed here, just so there's no confusion. Now, we are going to have to change some receives that receive these symbols. There's nothing that's sending. Oh, there is something sending to this receive symbol here. So we're going to have to change our speed, receives, and sends in this patch to playback speed and playback, so that way it kind of lines up and makes sense. Because we're going to have playback speed as well as grain speed as two separate things. So in order to do that, let's go through each subpatch and just check what we have. We open up this subpatch here, our loading subpatch. Grain size we'll be getting to, but here it says speed receive. This is so when the patch opens, it zeroes out the slider here, puts it in the middle at regular playback speed. But we need to rename it since we changed it in the slider. We got to call it playback speed receive right there. Okay. Next, recording. Recording doesn't have anything in it that addresses playback speed. Calculations, does. Basically, here is where speed received comes in and affects what the playback speed is. So here we need to say playback speed send. So this is where it receives from the slider, what the playback speed is. Here it receives normal speed, which is calculated at first when things are loaded, and the slider is positioned at normal speed, and everything's supposed to play back sounding normally, which it now does, that I made the fixes. Okay, where else here? Normal speed. All right, here. This is sending information to the playback speed received, so we have to rename this. Okay, now here we have a speed 0 send. This is from the bang on the outside that's supposed to reset the playback speed to normal speed, or zero it out basically to normal speed. We're going to rename that too. We're going to call that playback speed 0, because we will be making something else that also does a similar thing. And so when that bang is hit, it sends a 0 message to what is now called playback speed. Now you notice we do have the playback speed here that gets sent to the playback engine in its subpatch, which is right here. That we don't need to worry about. I'm just saving things right now, because since its name is playback speed and the send and receive symbols here are playback speed underscore send and playback speed underscore receive, it's not going to get confused with those two symbols. So it is its own unique symbol. But let me change this reset that we just changed internally to be called playback speed 0. Now we've already changed the one location where this is received. Okay? Good. Now what I'm going to do is test this. Now I don't need to close this, but just to remind you, anytime you're wanting to test your stuff, remember it's in the modules PD. This needs to be open. This is where the ADC and the DAC are actually located. So that's why I recommend just opening modules PD to do any of your edits, then right click on this to open this up. And anytime you save from here, Control S or Command S on Mac, you're saving the internal abstraction to disk as well. So the two files do get updated. All right, so let's go here. Let's record again and see if this still works. Let's record again and see if this still works. Let's record again and see if this still works. Let's record again and see if this still works. Let's record again and... Okay, all the functions that we renamed are working. So we've tested that out. We're good. Now, the way I'm going to just show calculations here just to kind of illustrate a point. In calculations here at the top, this is where information comes in from that slider, the playback speed, and allows it to alter playback speed based on what the normal speed is, either increasing it above that, decreasing it below that, and then it sends that information out to the playback engine called playback speed. So that's where we get it from. We want to do a similar thing with our grain size and grain speed. Grain size is basically our window size, and grain speed is the speed at which the individual grains get played back, not just the overall thing. And it allows for a different and a unique effect in and of itself. So we're going to add that. Over here at this size are calculations that take place after the recording's made to give us some starting information. But we are going to edit this a little bit. We don't need to change anything up here. Normal speed is a good name for the playback speed being normal. Okay. And then what I want to do here is say, okay, let's do the same thing with these. Instead of just grain size, we're going to have normal grain size. And we're going to have normal grain speed. Now, throughout this patch, grain size and grain speed don't have other names. They're just grain size and grain speed. But if we want to be able to manipulate them, it's better to give them a similar terminology as we have here, so that we have our normal size of grains and we have our normal grain speed playback. And then we can manipulate them and send out grain size and grain speed as far as what their altered state is going to be. So I'm going to rename those there, and then I should, before forgetting, go and do some of these other patches like loading. Instead of calling it the initial grain size, which is 100 or 500. I think originally I had 100. Not that it matters really, because it basically adjusts everything to a normal state. Like when the grain size gets sent out under now the new name normal grain size, that will just be its normal size, and the normal grain speed gets calculated from that, which we just did here in calculations, just so we don't get lost in this. Here, let's go to calculations. See, so now when the patch opens, 100 is automatically sent out as your normal grain size. Sampling rate is also automatically sent out from that same loading subpatch. And then the grain size being divided by the sampling rate gives us our normal grain speed. Okay, now our playback engine won't work right just yet because we didn't do it, because the names in here are different, but we don't want to change those. We want to do this differently. But we do want to change it here in window. Well, not yet. You see here in window, your grain size and your grain speed will create this window. But rather than this just always being locked into normal grain size or normal grain speed, we want this to be alterable. So we're going to leave this say grain size and grain speed. What we want to do is in calculations, allow ourselves to create what the grain size and grain speed are based on manipulating normal grain speed and normal grain size. So just kind of like, we could almost, just to start, copy this, grab it while it's blue and highlighted, and then move it down, or else you'll have a mess there, trying to work out which object's which object and move them down together. So yeah, this is where it will receive, and we're going to make a slider for this. Receive grain speed underscore send. We have to make that slider still, but that's what it's going to be named. Here's where it will receive normal grain speed, so it can calculate what your alteration based on the slider is going to be. And here is where it's going to send out just regular grain speed, which is being received in other parts of the patch already. So now, the way we have this set up is because the slider goes from -1 up to +1, we have a Moses 0. So anything below 0 goes over here where it's swapped with a 1. Basically, a 1 gets added to it. So let's say it's -0.01. 1 gets added to it, it becomes 0.99. And then what gets added to that is another 0.11, which would make it 100. Now, if it's lower than that, like if the slider's pulled down closer to -1, let's say -1 itself, when it comes through, swap 1 minus -1 equals 0, plus 0.1 to make sure it never actually is 0, because then you won't get playback. So basically, we have a range on this side, as your slider moves from 0 to -1, a range of basically positive 0.01, or actually here I'm just saying 0.1. I guess we can leave it at that and see if we want to adjust that later. But basically from 0.1 up to, well, the further it's down, the more it is 0.1, and the further it is up closer to 0, the more it's closer to 1. Okay, so it's basically an inversion, and that gets multiplied by the normal grain speed. So it's like a percentage. It's just the further you have the slider down, the slower the result's going to be. In other words, the lower the grain speed will be. And the closer you have it to 0, the more close to normal grain speed it's going to be. And that's where the right side also comes in, because from 0 and above refers, we're basically making it 4 times as fast as maximum, and ranging from everything up to, from normal speed to up to 4 times as fast, which is what we have up here. And so we're going to see how this works out. What we're going to also want to put here, let me move this over a little bit so they can stack. Trying to organize things so similar things stack on each other. We're also going to make a reset button for this. But let's see what we have here. Normal speed. Isn't that supposed to be normal playback speed? No, I think playback speed we have calculated as normal speed. Maybe I need to rename that. Here it is. Yeah, instead of normal speed, let's call it normal playback speed. Because we're going to have a normal grain speed as well. And this differentiates the two. Here's where that gets first calculated, and then it gets received here. And it gets received up here. And that's where it sends out the actual, oh, this is just for when it first gets calculated. As soon as normal playback speed is calculated, it just triggers a 0 to go to the slider, the playback slider. But here, this is where the reset button can 0 out the slider. And here is where it gets part of the calculation. So we renamed it enough. But here we're going to have normal grain speed, which gets calculated down here. Normal grain size, normal grain speed. Okay? So that gets calculated there. What we need to do is now make the slider for grain speed send. And we'll have a corresponding receive and a reset button for it. So let me, we're going to see if we need to make this any bigger as we go. But I'm going to do this, like you see the reset is, the label is appearing next to it. That's where Vanilla likes to put it by default. And when things got zeroed out from bringing it in from Lork, that's what happened. We're going to make it 0, -7. Yeah, that puts the word reset on top. So it goes along with playback speed. Okay. And then I'm going to do that here quick with these, just so that they look good. Anybody that's doing this for a class with me, you can make things look the way you want. The only thing is they got to work. You know, you can use the colors you want. You can put the labels where you want, you know, as long as it makes sense and it's readable as to what it is and the user can use it, and that overall the patch works. Let me see. You can also use arrow keys when you select things to kind of move them slight amounts like that. All right, so we're going to duplicate these and rename them for grain speed, which means here, properties, we need to make our window taller. The y-axis, let's say 280 for now. And it might have to get bigger later because we're going to put in one more slider. So let's change this slider's properties though. Because now this is going to be, this one here is going to be for grain speed. I'm taking out the words playback and putting in grain. We label it here. And then I'm going to change its color so it has a different one. And then color coordinate it with this reset button to be the same color. So we have, it's easy to see which reset button goes with what slider. Grain speed. Yeah, it's called grain speed 0, receive, and grain speed 0, send. The word reset will be obvious that it's to reset this one, the slider the same color. Now let's go back to our calculations here and make sure, yeah, we didn't put in the reset for that stuff here. Because we want the same things to happen, but for grain speed instead of playback speed. When normal grain speed is calculated, and that's basically after you record in audio, you know, that's when normal speed and normal grain speed get calculated over on the left side of this subpatch. This tells it, it'll tell that slider to 0 out. And then here's where the bang tells the slider to 0 out. So we need our reset bang. Grain speed 0, send to here. Grain speed. Now, I would test this out at this point, but it still won't work because we have grain size here. But what we can do is test this out by putting in a temporary thing. Receive $0 $0 normal grain size. Because that's what we have so far. That's what gets calculated automatically. And then what we have in the patch, in the playback engine of the patch, we just have something called grain size. So we'll send that out here. We'll just say, okay, it's the same thing for now. So when normal grain size gets calculated, it will automatically become grain size because that's what it's called inside the patch. Because we didn't make this stuff yet for grain size, for a slider's interpretation to be put on it. Okay, let's just test this. Does this work out here? Boom. Now to test this, we could just save it, close it, and open it again. Or we can go here to loading, hit this bang that I put in here internally so that we could bang our defaults to start. And then we should record a new sound wave so it goes through that routine. Hello, how's it all going? Hello, how's it all going?
Hello, how's it all going?
Hello, how's it all going? Hello, how's it all going? Hello, how's it all going? Hello, how's it all going? All right, so our regular speed function works. Now let's hear when we change the grain speed. Hello, how's it all going? 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 Hello. So you get when you throw your grain speed out of alignment, you're going to get some distortion. Now let's try something here. Hello, how's it all going? How's it all going? Oh, how's it all going? So the main thing is with grain speed, you are going to get distortion. When you make it faster than normal speed, then it makes some pretty intriguing sounds. Down here, I don't know if it's as useful, but that's a matter of taste, you know? And I might just make a slider that, you know, goes from here all the way up and come up with a different range for it in order to get, you know, the kind of range of sounds that I want. But if you want things to sound smooth and shifted, we just go back to our good old friend playback speed. Hello, how's it all going? Hello, how's it all going? Hello, how's it all going? So what I would do is, because we have in our calculations the ability to change these ranges, is I would go in and kind of like work on what calculations would make sense for the ranges of sounds that I want to make. But right now we're seeing what we can make with these things and changing these properties. And we always have the ability to reset them and zero them out. Hello, how's it all going? To where they sound normal again. All right, so next, and this will be the last thing to add as far as sound manipulation is concerned. This is going to be the window size. And I'm just going to take these controls here and duplicate them, although the calculations on the inside are probably going to be a little different, I think. But I'll see which ones I want. And here, how about orange? There we go. Well, I actually do need to rename things because we're going to make these the sliders for green. Now it says grain size 0, but zeroing out means just resetting. So that's fine with me. I know what I mean by that. Grain size 0. It's not like the speed goes to 0 when you hit the reset button either. So size 0. So this will be for resetting the size. And that, in our calculations, we'll set for something like 100. Now here, this is going to be grain size. And up here, we'll put in grain size instead of speed. P-E-E-D goes away, S-I-Z-E. This stuff, always got to be careful renaming things. Okay. Now we got to put it in calculations and we got to extend our view down a little bit. Let's see. How about a good even 300? Does that look good? Not quite enough. Try 320. That might work because I could probably move this up a little bit. As well as this. Select these. There we go. This looks a little lower than that, so I'm going to hit the arrow key after selecting it, and that brings it up. Okay. We don't need to edit any more properties. Sorry about that. I'm going to save here at this point. Everything we need to do is still in calculations. Now this is going to be different. So first of all, we got to get rid of this that we use temporarily to automatically calculate grain size. Now we're going to calculate it based on the slider. Although we're going to make something like this here, where we're going to receive, and this will come right at the beginning when things get banged there in loading, receive normal grain size. Control 1 to trigger float bang, just like we have above. And we'll let the float come out into like a number box here so we can see it. And then we just have a bang to 0 the slider. So that's what we're going to put here. A bang to hit this 0. Message. Send $0 underscore, what is it called? Grain size. Probably. Grain size. Oh, the slider. Yeah. Grain size receive. Although I'm going to double check that. Which is being sent to this guy right here. Grain size, all one word, receive. Yep. Okay. What am I doing? I was thinking one thing, doing another. We're going back to playback, not playback, calculations. Okay, and now We also need this for its reset button. Let's duplicate this and just rename it for purposes here. Basically, grain size 0. Send gets received here to send the 0 to the slider. Grain size underscore receive. Okay. Now I have those functions in. Now comes this part. How do we want the slider to be calculated? Now this is different. Here we're doing speed things, and roughly we're going from like 10% the speed as like the low minimum slowness of the speed could get to, and then 4 times the speed as far as how fast it could get to. All right. Now, we're talking about window size here, so if we're starting at 100, I don't think we want to go below 1, first of all. And then I don't know how high we want to go. We'll see. We'll try a couple things and test them out. Receive $0. I'm typing and I'm not in the box. Receive $0 underscore grain size underscore send. This is what's coming from the slider. It'll go to Moses 0 because our slider is still going from -1 to 0 in the middle to +1 at the top of its range. And we can do all sorts of calculations to manipulate it from there. Now, I like this for the bottom side, so we're going to keep it. The bottom side of the range will still be from like 0.01 times whatever the normal grain size is, which is 100 to start. That'll get multiplied down here. So let's make a star tilde for that function. And then I put number boxes here just so I could see what values get calculated. And so when I hear things and see a number, I get an idea of whether my range is something desirable or not. Grain size. So this is where grain size gets sent out to the playback, because that's where it gets received. Not normal grain size, that's the one to start. This is the actual grain size. So we could change our panning window size as we go. And now, what are we doing next? Let's put this in. I'm just borrowing these things and renaming them. But this is where our normal grain size comes in. And then it will get calculated over here. Up there, it's kind of more in line with this, I believe. So that's fine. There we go. And now we need to do the middle bit here. What happens when you move the slider up? Well, this is going to be on a range of 0 to 1. So we'll just multiply that by 10. How about that? So it becomes, come on. Which one's star? There we go. Times 10, or how about 100? But since our normal grain size comes in at 100, here it gets multiplied where it could be Well, if it gets multiplied, we can't have a 0 here, because that zeroes it out. So we'll have to make it times 99 plus 1. So then its range really becomes 1 to 100, where it's like a percentage. Normal grain size to start, and as you move further up, it can be up to 100 times the normal grain size, which in this case would be like 10,000. And we'll just see how that sounds, and we'll see if these range numbers work out for us. Now, what we need to do, I'm going to save here. You can either close and open it from the start, or you can go here and record something new. Okay. All right, let's record something new from the start. All right, let's record something new from the start. All right, let's record something new from the start. All right, grain size isn't working. I'm hitting the reset and it's not doing anything, so we got to fix that. Grain size, 0_send. Grain size 0_receive. In calculations, there's got to be a typo. Here's normal grain size being sent and zeroing out the slider, which did not happen, by the way. It was received. It did bang, but it didn't get there. $0_grain size_receive. I have to check the slider, folks. Grain size 0_send. It's correct here. But let me show you here. Here it's setting to grain size_receive. Let's just hit this in run mode. What am I keep making stuff for? Hit this in run mode. And our slider didn't zero out, so it must be in here. Grain size, there's 2 S's. There we go. Some folks may have seen that when I was making it. Like he'll be back at that later. Okay. Let's try this, zeroing it out. There we go. So let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. Now, you notice you didn't hear anything when I lowered the size. That's because you really won't hear much of anything until we start manipulating it. Hold on, but let me check something. Let me check in calculations here. Normal grain size does automatically change normal grain speed. But when you just change grain size, it shouldn't change the speed. Let's see what happens. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. We can do.
Let's start over again. Let's start over again. Let's start over again. Let's start over again. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do. Let's start over again and see what we can do.
Okay.
Let's start over.
After my experimentations, believe it or not, what I'm feeling. Okay, folks, I had to do a big edit here. I was recording the video, on the fly, pausing things, unpausing things, and stuff like that. And basically, I'm coming back now after the fact because I guess something I did inaccurately with my hotkeys, and there were times when thought I was paused and I was unpaused. Times I thought I was unpaused when I was actually paused. And so I had to cut from where it last made sense in my video. And since then, I've added some things. Now, if you've been up with me up until where I'm just cutting into, we have successfully got everything working as far as playback speed, the grain speed, and the grain size. This is all working. I was experimenting with it, and then I got some idea where I was thinking, well, it doesn't look like grain speed's doing enough good stuff that I like, and then I started futzing around with it and basically screwed things up. This granular synthesizer does offer a lot of parameters. Some of them are less desirable sounds than others, but that's something I'm going to experiment with as I work on it and stuff like that. But right now we have a functioning granular synthesizer, and you can see some of the major aspects of how the sound is being transformed. So, I've accomplished what I set out to do as far as teaching about granular synthesis and what it is, and building one from scratch. Now, refining the parameters and stuff like that, that'll take more time and to develop it. But what I do want to add to in this, before we let this go, is open and save functions. First of all, these fonts are different than these fonts. So I just want to check that real quick. Oh, that's right. This is an abstraction. I need to go inside it. And I'm going to show you basically the mechanisms I made for open and save so that you can apply them to your own. It's just being as anal as I am. I do want to deja vu sans mono. And offset, and it's size 10. Okay, let me make this. I mean, I was doing this in PD Vanilla. It must have been when I was using Lork the other episode that things changed. Well, it looks like, okay, the font size, just make it 10. It's the same font. There we go. They're just bigger. Okay, so I got that worked out. But anyway, these are just bangs for open and save. And on the inside, other than this font that I've been changing before actually getting towards teaching, you see there's a send symbol, $0 _ open _ send. And then I also have the receive, even though this isn't really being used. A lot of these GUI controls, there isn't anything being received, but I always put one in anyway. I don't know why. But definitely one thing that does receive things are these sliders. So those are being used for sure. And then this save button, I have the same send and receive symbols, $0, $0, _ save _ send. So these are communicating with, all you have to do is basically hit these and you get an open panel or a save panel. And that's for opening and saving files. Now what I want to do, let's get the right window up here. This is where we've been working in. This is our folder. And what I do, and remember, this was all, made a lot more sense when I recorded it a while ago, and I was unfortunately paused while recording. Oh, man. So this is after the fact where I'm just showing you what I did. When I was doing it, everything went more smoothly. But basically, this is our folder with our modules and our granular_mono file, the two PD files. I made a folder called audio, and this is now where audio is going to be kept for this whole patch. So whatever folder name you put this in, as I show you these things, basically you'll want a subfolder named audio, and that's where all your audio can be saved and opened from as you go, and even the temporary file gets written there. All of this work is in the recording subpatch here. If it'll open. Usually in run mode. Okay, let's try. Okay. I'm looking down here to see if I can find it. What are you doing, PD? Other than things have just not been going my way today. This is the recording sub patch that I'm trying to call up here, and it's just not doing it. All right, so let me close this. Yeah, save. How did I have multiples of them open? I don't know. It's just, and where did my folder go? Now my folder's gone. Oh, for crying out loud. Sorry you have to hear my frustrations and all that stuff, but man, it's been with the recording and just, I must have just hit the wrong hotkeys at the wrong times and stuff. That must have been it. But this isn't helping. I don't know why PD is doing this. Okay. Open. And usually you can just, I'll right click it anyway, go to open. And the recording subpatch, is it on my other screen? My other display? Yeah, I guess that's where it is. I wasn't editing it over there. In fact, it was like shifted to the right of there. I don't know how that happened, but there we go. Okay, so here's my recording subpatch. We're familiar with this section. We've been doing that. And then this section for basically recording. And of course, it records to a file named recording.wav. And then that file gets opened here after recording stops and gets written to the table. And we've adjusted this along the way to deal with, using the $0 and also being able to, load to the table more effectively, basically. But then this is what I've added here. Here's a receive for $0_open send, which is the open button, the bang on the outside there in the parent patch. This taps a dir message that goes to PD control. The PD console or control window is that window that opens up when you open up PD or you open up a PD file. It's your feedback about error messages and everything like that. But it is considered to be an instance of pure data. And so when I opened this patch, modules.pd, it then knows about modules.pd. And basically by sending the dir message to this, you're telling the current instance of PD, what directory is this patch saved in? And then that gets sent out. Once you send that message in, it gets sent out. And then by using a message that says symbol at the beginning, and then here I put $1/audio. What this means is whatever folder the patch is saved in, go into a folder deeper in there called audio. So, sorry, this is another folder. That's where I'm recording things too. I thought I still had my folder open. Oh boy. Well, basically, in the folder where I'm keeping things and where this patch is, there is a subfolder called audio. So that's what we're queuing up here. And by sending that message to open panel, a panel opens, basically, your open file browser that you would get anywhere. But basically, by sending it this message, it's going to be opening starting in whatever folder this patch is in, a subfolder called audio. And that's what I showed you at the beginning of this portion of the video. And the open panel opens there, and basically what happens is it triggers a symbol and a bang. The bang is just to hit this symbol box that sends the symbol $0 waveform. Remember, this is just because the $0 does not open up in messages, and so we have to use an object to send the name of our table forward. So basically, this is the name of our table being sent here to a pack as a symbol, and also as a symbol is being sent the file name, including the full location address, like C:/document/ whatever your file location is, gets sent here to the read resize $1 $2 that we're already using to open the file that we recorded. Now, one thing I should add to this is here, see this symbol box? I put audio / before the file name $0 recording.wav because I'm now keeping the recordings in that audio subfolder, so it's the same thing here. And the same thing here. Audio / $0_recording. Basically, it's the audio / that I added to both of these messages. Well, this both of these objects. So that symbol gets sent as the file name symbol that whenever we record. But now whenever we open an audio file, it's basically going to go to that folder, audio, and allow you to select the file there. All right, and so that basically takes over right here for whenever you open a file rather than just record it. It uses the rest of the same mechanisms, so SoundFiler puts out the sample length that we need. Then over here, we have our save bang on the outside. It sends to here where it bangs the same dir message to PD control that then goes to this symbol box. Once again, it's not a symbol box. This time it's a symbol message. Both of these are symbol messages saying $1, meaning the first thing that came through their inlet, /audio. So basically, whatever directory you're in, add /audio to it, and that's the place where you want to open your save panel. And then for the save panel, it triggers a symbol and a bang, once again, like over here, except it packs all this stuff up and writes it to a different sound filer. I just didn't want to use the same sound filer because since that's connected to sample length, I don't need it to output any messages that might mess that up. So I used a different sound filer just for saving. But basically, students of mine, please check out this screen. Please correct these, make these two changes here so that the audio subfolder is used, and then add these things for these functions. And now what you're able to do, as I close this off, basically I'm able to open and it goes straight to this folder. See, my main folder with my stuff in it is episode 04 and the subfolder audio. It's just I just set this up so you can conveniently go to this folder. I can record then open up a previous recording, play it back. Here is audio recording 1. We can even write the one that is there. Here is audio. And we can play with that. And then when we're sick of that, we can open up and something else. Of course, it's good when you open up something new, maybe to reset these, which we can now do. And now I'm recording a second recording to have on hand. There we go. So that was the demo I made earlier when my video on the fly editing skills were lacking, and I've had to make up for it now. So that's what's new with completing this patch as it stands now. It's time to move on from granular synthesis to other topics, but I will come back to this granulator in the future in other series when I make it into a synth module that could be compatible with other synth modules for basically making like a virtual Eurorack type system. And but for now, we've got a functioning granular synthesizer, and that was our goal. Let me see if I can get a decent screenshot of it. And I'll thank you for joining me. Till next time, take care and stay free.